You're listening to Body Banter, a podcast where we have conversations about the human body in all its forms and from as many perspectives we can find.
We are your hosts, Segun Oyedele
and Claudia Krebs.
And we are professors of anatomy in the Faculty of Medicine at the University of British Columbia in Vancouver, Canada.
Anatomy is for everybody and every body, and we're here to get the body banter going.
We hope you enjoy this episode. Hello, everyone, and welcome to this episode of Body Banter. My name is Segun Oyedele, and I'm speaking today from Kelowna. Kelowna is in the traditional ancestral and unceded territories of the Silk Okanagan Nations. And as usual, I have with me Claudia. Hi, Claudia.
Hi, Segun. Nice to see you here. I'm joining you from the UBC Point Grey campus on the traditional ancestral and unceded territory of the Musqueam Nation, and it is a beautiful sunny day here on the coast today. And I am so thrilled about our guest. We have Valerie O'Loughlin here. She is a professor and a highly decorated educator. So not only has she won the Henry Gray Educator Award from the American Association for Anatomy, but also the AAA Mentorship Award, which really speaks to Valerie's dedication to education, both in the undergraduate and health professional classroom and for her graduate students, where she is known to be a terrific mentor and ally. Valerie, we're so happy to have you here.
Thank you so much, Claudia and Segun. And if I could also acknowledge and honor the Miami, Delaware, Potawatomi, and Shawnee people on whose ancestral homelands and resources Indiana University was built. It is a pleasure and an honor to be here with you all.
Well, the pleasure is ours. Valerie, tell us a little bit about yourself and your journey into anatomy. Like, how did you get to this point in your life and in your career?
Thank you, Claudia. Well, my path was definitely meandering. And I would tell most people that if you expect a direct path to wherever you think you're going, don't expect that. I was pursuing a PhD in biological anthropology at Indiana University, which I received. In the process of getting this degree, one of the courses we had to take was the dreaded gross anatomy course with the medical students. And I had never taken an anatomy course before. I spent a lot of time studying osteology and bones and examining them in detail, but never with fleshy parts on them. People who had taken the course said, this is going to be a really tough course, just try to survive it. And I took the course with several of my graduate student colleagues and the med students, and it was the toughest course of my career. It was the first course where I realized I did not have effective study strategies. I had been able to get by. And in that course, when I started to struggle, so I had to adapt and modify. And while the course was very challenging and there were times that I definitely felt like an imposter and a fraud being there, wondering, why did they let me in here? I don't know what the heck I'm doing. Did finish the course, did pass the course. And I remember rather humorously the last day of the course, throwing away my scrubs, going, well, I'll never need to use those again. So karma has a way of coming back to you, as I now have gone through many pairs of scrubs throughout my career. After that course, I ended up pursuing a minor in anatomy. So I took microscopic anatomy, I took pathology, and I really found it interesting. And in our graduate program, a lot of graduate students got their teaching assistant funding by helping teach the undergraduate anatomy course. So that's what I ended up doing for funding. As I was finishing up my PhD, I was applying for a variety of biological anthropology as well as teaching anatomy positions, and a part-time, a full-time but non-tenure track 1-year visiting teaching position came open at our institution because the professor I had for gross anatomy was retiring. So I was hired on a 1-year visiting basis. That 1-year visiting basis became a 2-year, became a 3-year, became a permanent non-tenure track position. Then I got interested in scholarship of teaching and learning and education research. And because of that research and working on textbooks, anatomy and physiology textbooks, my position was converted to tenure track, and I became ultimately a tenured full professor of anatomy. So a very meandering path. Whenever I see grad students saying, but this is my trajectory and it's not going this way, I try to tell them that just go along for the ride.
That's so fascinating, Valerie. What comes through straight away is just your ability to communicate. That's great, and as well as your love for mentoring. The fact that your first instinct is to tell younger people, say, if you expect your path in academia to be straightforward, don't do that. So that just shines through for me, and so from that meandering path, it's been, a whole many years now since you embarked on your anatomy career. What has stood out for you over the years in terms of the way things changed in terms of teaching and in terms of learning then and now? What are the similarities that you see, and what are your big highlights? If those could be summarized a little bit. Yeah, I know there will be many, but
Yes, I'll do my best to summarize and fail miserably at that. I would say that, well, in terms of the field of anatomy, I think we've all seen the field of anatomy make great changes from the early 2000s to today. We've seen the retirement of many of the classically trained anatomists. Many people who get degrees in anatomy now, it's typically molecular biology related, and most of these individuals um, maybe looking at genes or tissues, much less, they rarely look at an organ or much less an organism per se. So some of the people who are trained in these degrees aren't the ones who are most qualified to teach the courses. And many of us in anatomy recognize that needed to change, that we definitely do need to train and educate future anatomy educators. One of the things that I have seen for the positive, especially for in the past 20 years, has been the development and growth of the Scholarship of Teaching and Learning Network, that people recognize that strong, rigorous education research in your discipline is not only desirable, but required. So instead of having people say, well, I did education research, I asked my students if they liked it, and they did. You're now seeing really good quality, multi methodological projects that are out there. Also, I think the tide has changed, or the tide is starting to turn, if I may mix all of my metaphors, in terms of no, not accepting mediocre teaching. One of the things that I've seen change for the good is that individuals are recognizing and appreciating quality teaching that is founded in discipline specific education research. I am thrilled to be able to run an education track and anatomy PhD program, and I have seen anatomy faculty from across, actually internationally, come and ask, we want to have your students teach in our classes, because they recognize that a good teacher can impact so many more individuals than someone who may not necessarily have their heart in the system.
Well, I can confirm that your graduates are amazing and they're very sought after because of this combination, and also because of the passion for anatomy that you instill in them. One of the things that I find so rewarding, well, one of the many things I find so rewarding with getting to speak with all of these wonderful people on this podcast, is that the passion for anatomy and the passion for the human body always shines through. It seems like we anatomists have this very unique relationship to our discipline. Like, nobody does this as, yeah, I guess it's what I do. Everybody's like, oh my God, it's like the best thing ever. And I'm so thrilled to be able to be in the classroom every day. What do you think makes that happen to, well, pretty much everyone I know in the field?
That is a really good question. And I completely agree with you about the passion. And maybe perhaps there is a system where only those who are truly passionate are the ones who persist. So there may be a little bit of positive feedback there. But I think for every single anatomist that I've interacted with, their desire to learn their pursuit of a challenge, uh, their love of puzzles, to figure out how things connect and interact, and how things can change. That seems to be a consistent theme there. Also, I would say that you can be enthusiastic about a lot of things, but there may be a little bit of an ick factor that may turn some people off. That I would argue, get past the ick factor, and once you get past a potential ick factor, you realize how incredible the human body really is. And I would also say that anatomists also have a great appreciation and respect for the individuals who have donated their bodies so that we can learn. That is always underneath everything. That beyond that, gee, wow, you recognize that this is someone's grandparent, child, spouse, and they willingly gave this gift so that others can learn. And I know from my perspective, I want to make sure that that's not wasted.
That's so true, Valerie, because I remember my that anecdote from, I mean, it relates to me totally because my first anatomy class as a medical student, I did not enjoy at all. I did not like the dissection experience at all. But once I got over that, you couldn't keep me away. So much so that in our yearbook, I remember my table classmates wrote it in bold letters. Shogun was the dissector on our table for all our time in the anatomy class. So I mean, I mean, it wears on you. You just learn to, it grows on you. And I enjoyed it. And so you're so correct for that. I want to kind of raise maybe a slight tangent, but still related, in the sense that that traditional view of science and teaching, that there's that dichotomy about the fact that teaching and scholarship of teaching and learning is like a poor cousin of the actual rigor of science, and I'm sure that must have come up in some of the conversations that you've had. How do you respond to that when people maybe who are not as knowledgeable in this area approach you and say, oh, but yeah, I want to teach, but maybe I'm not going to get to the same academic level excellence and recognition that I might have if I pursued just a science-based, just research career. How do we relate, and how do we respond to that?
That is an excellent question. Earlier on in my career, I did feel that education, research, and scholarship of teaching and learning had been looked at as the poor cousin. And in part because I think some earlier discipline-based studies were not as methodically developed, and individuals did not have a good understanding of what it takes to be an education researcher. As more individuals are becoming involved in the scholarship of teaching and learning and education research, as we are seeing the development and the increased impact factor of education research-based publications like anatomical sciences education and advances in physiology education, as we are seeing individuals progress through graduate programs that are focused on this, we are seeing individuals recognize, yes, this is a legitimate and valid field. Very early on, when it came to education research, and I had bench researchers ask me, but you can't control for this, they're students. I like to bring up the aspect of clinical education and clinical studies. In clinical studies, you're dealing with patients and all sorts of variables, and yet clinical studies didn't get that kind of dismissive attitude that education studies did. Another thing that helps is the future generation that is coming up and leading the way, and that are now presenting and have the faculty positions. I had several individuals at my institution in my program who were bench researchers who had said, wow, your graduate students are really head and shoulders above so many other graduate students we've seen here. So I think the proof is in the pudding when we see the individuals who are out here and what is being accepted as noteworthy. Also, too, there has been a dramatic influx and publication of how people learn from 2001 when National Press published How People Learn and then published the sequel in 2018. Individuals recognize that there is a cognitive science basis involved in teaching and learning, and that we should be approaching education the same kind of methodological progress that we do with any traditional bench-based research experiment.
Yeah, thanks, Valerie. That's such a really good point, because people used to think, like, I'm an expert in my field. I can just stand in front of a class and tell them all about it. Well, turns out that's not super effective. And understanding the science of learning and the science of memory helps us be better educators, to convey the information in an interesting and in a way that it sticks, right? You've done a lot of changes in the classroom. You're known for that, especially for really difficult things like embryology. And I always say this, people who've listened to more than one episode here have probably heard me say this before. Almost every anatomist is a closeted embryologist. Like, we don't really want to admit to it because it's like so complex. And I'll be the first to admit I'm not an embryologist in the sense that I know any signaling pathways, but I kind of need the understanding of how things kind of fold together into the human form to understand why things are the way they are. So I guess I'm maybe a conceptual embryologist instead of a pathways and signaling molecule embryologist. You've really made a deep dive into this, and you've created educational media for this. What's your passion for embryology, and what's your approach to teaching it?
Thank you for that question. I guess a common theme in my life is some of the things that I've ended up persisting in have been things that have most frustrated me. So if gross anatomy frustrated me a bunch, embryology really, really frustrated me to the point where I didn't understand what the heck was happening. And again, and as
For the listeners, everybody's here with a big grin and nodding because we all relate to this. And if you're an anatomy educator or student, you might be nodding and grinning right now as well, because yes, carry on, Valerie.
Oh, it is so true. And I can remember as a graduate student thinking, well, I did that embryology, but thank God I don't have to touch that again. And then I have an anatomy position and I have to teach embryology to medical students. So it's not even like I can, fluff it. And I thought, oh my gosh, I really have to try to understand this. And this was in the early 2000s, late 90s, early 2000s. I'm looking at my texts. They were very good texts, but with the static two-dimensional images. And I see image A at 3 weeks, image B at 4 weeks. And I'm trying to, my poor little brain can't figure out how image A at 3 weeks got to image B at 4 weeks. And I said, if only there were these movies or these animations that we could have to develop them. And that actually started a project with some grant funding where I worked with a series of medical illustrators and graduate students to develop a series of two-dimensional embryology animations, because I recognized that is was one of the biggest roadblocks for me and for students when they're learning this subject, that not only do they have to learn all the different parts, that's an anatomy, but now you have to learn how do all those different parts change over time, that fourth dimension, which can end up being a deal breaker. So, and then it helped me recognize the limit of my understanding when I was working with medical illustrators who may not know very much about embryology. And they kept on asking me very detailed, probing questions so that they can understand. And I would realize, that's a good question. I just glossed over that. I better go back and double check this. So, in the process of trying to create these animations, selfishly, they helped me understand the subject even better. You and I have talked about this before, but one of the things that I love about embryology is that it can help explain so many things in gross anatomy. So there is a mantra that I tell my students, and I have them sit in yoga. I tell them sit in yogi position, put your thumb and index fingers together, and then repeat after me. If something doesn't make sense, we blame embryology. And that ultimately is the case. Embryology is the key to answering so many of those anatomy puzzles. How could you not love it? And whenever I hear a student saying, well, yeah, I see how embryology does this, but this is really tough. I'm not going to love it like you did. And I'm like, nope, nope. I was that fraud. I was that imposter who didn't get the embryology, who thought I would never get the embryology. Now I'm starting to, and it's answering puzzles. You will be there too, as long as you continue to persist and try to work out the puzzle.
Well, you're an expert in embryology now, I think is fair to say, because while I'm remaining in the sphere of conceptual embryology, like this is how things kind of move to make the human form, you actually know all of the signaling pathways and understand them in a very profound way, and are able to communicate it expertly. I mean, we've worked together on a module which was really tough, again with a bunch of biomedical illustrators. Do you want to talk a little bit about that project?
Yes. And this was part of a sabbatical. Like one of my sabbatical was to come to Dr. Krebs' Hive Laboratory and to work with some of her students to develop a genital embryology animation. In my series of embryology animations, this was one of the areas that had been the least developed. Plus, there's been so much more that has been learned, and our understanding of sex and gender has become so much more developed and nuanced since then. And frankly, it's become less sexist. In the past, with genital embryology, there often would be a discussion of, well, here's the male genital pattern. And then, but if you don't have all of these signaling pathways and molecules, then female's the default. That's not the case. And researchers are recognizing that no, they are both equally formed and developed. And actually, I realize as I'm speaking, when I use the word male and female, I am using the terms with respect to the phrase phenotypic male and female. We are aware, scientists are aware that sex is not a binary construct, that there are numerous variations of chromosomal sex, of which XX and XY are the most common. There are numerous arrays of phenotypic sex, of which what we call phenotypic male and phenotypic female is the most common. So I saw this um, development of this team project to bring in some of those layers of complexity and our understanding of that sex and gender neither are binary constructs into a module that as many people as possible could learn from.
Valerie, this is so important. We are right now in August 2024. The Paris Olympics are going on, and there's a lot of talk about phenotypic sex and genotypes, phenotypes, hormonal influences, pathways disrupted in development or not, because a lot of folks don't understand the gray zone that exists between the most common clusters where genotype and phenotype are congruent the way we would expect them, but that there's a lot of in between. How do you deal with that uncertainty and that gray zone in your classroom and in your own head?
That is an excellent question. Among the things that I try to do is I try to educate my students that neither sex nor gender are binary constructs. I mention about what is the science behind that, and emphasize that I am not espousing a political belief. Here are the scientific facts for such. That said, when I talk about various anatomic structures, one of the things I try to do is to not introduce gender terms when they're not needed. We don't necessarily need to say the female reproductive system. We can talk about the anatomy of the ovaries, uterus, and uterine tubes, because not everyone who identifies as female has those structures. Likewise, there may be some individuals with an XY chromosomal complex who may represent with um, female-like external genitalia. So if we can simply move past some language that doesn't need to be there, and it's making a classroom more inclusive, why not? And again, it's not espousing a political belief or anything like that. It's simply just trying to recognize the complexity there. And I have voluntarily heard from students, as well as seen on my teaching evaluations, that students have said, I really appreciate that you approach the subject with a sensitive and thoughtful manner. I have not received pushback from students with respect to that. Again, because I think I'm approaching it with respect to here is what the science says.
Excellent. Kudos to you, Valerie. I think that this is something that is much needed. And to me, I think this is an example of what we've been talking about earlier, about where the rigor of your studies, the rigor of your research and scholarly work feeds directly into your teaching and is able to advance knowledge in that area. And so how you are able to use those terms and to say, what, from my research and from my understanding of the science of this, it's just why not just teach about the anatomy or the embryology of the ovaries of the uterus and the uterine tubes? And I think I'm going to take a lesson from that because I do teach this area, and that I'm going to change my language and begin to actually speak directly of those anatomical constructs rather than use gender-based or sex-based terms. I think it's fascinating and is really helpful. So I'm learning from you, Valerie. Thank you.
Well, thank you. And in full, I also want to mention that in terms of my students in the classroom, it's been positively received.
Excellent.
There have been some more conservative outlets that have made claims that there was an agenda being promoted. There is something called the Professor Watch List, of which I was put on there because I made the comment that both sex and gender are non-binary and presented the science facts. So I wanted to be completely open to individuals that sometimes in this political climate, there may be a bit of pushback, but I will wear that as a badge of honor if it means that I am stating scientific facts and not being not being forced to not teach scientific truth.
Thanks, Valerie. A lot of respect for you for standing up for science. And at the same time, it really is a call to action for all of us to get more science into the broader community, because it shouldn't be a question of political discussion. It should be a question of discussing facts and nuance and becoming more comfortable with that gray zone. Like, not everything is on a binary, not everything is as it appears. There are layers to unwrap. And you are a true proponent of bringing those aspects of embryology, of teaching, of anatomy forward. So thank you for being a leader in that field. I think it's a huge service to our community and to the world, really. We need to get the word out there. Thank you.
Another area where I have benefited from your work in animation is the embryology of the heart. The very first animation that I actually built on and stole, full disclosure, stole some of your drawing and some of those animations from your website, was on the embryology of the heart. And how did that start, and how has it progressed up till now?
Thank you for that question. And by the way, I have seen your embryology of the heart animation, and it is fantastic. And it built upon things in ways that I never would have dreamed. So I'm glad that I was able to provide the initial impetus for you to create a superior project. The embryology of the heart was actually my first venture into embryology and development of animation modules. I was tasked with teaching the embryology of the heart, and I realized it was very difficult. And I was standing up in the classroom with sheets of paper, trying to twist them into little S shapes to show the S-shaped heart. And the students would look at me like I had a third eyeball stuck in my forehead. And I realized there's got to be something better. So I worked with a I worked with an illustrator. This individual wasn't even a medical illustrator. He was a graphic design artist at Indiana University. And he and I worked, and it was creating two-dimensional Apple movies. Anyone remember Apple movies then? And then eventually we went on to the whoop-de-doo flash animations. spoiler alert, folks, Flash became no more in 2020, working with that individual. And he was a wonderful, lovely gentleman, but had these honest questions. We're like, well, what goes on here? And that's when and he helped me tune into, I need to know more about this. So in the process of developing those animations, I did some education research work on this to examine the efficacy. I've published with several graduate students on it. So the animations and the education research went hand in hand for this development. And thanks to you and thanks to Claudia, you all are now utilizing much more advanced technologies than we ever did. I am not well versed at all in any of these technologies. I gave the expert in embryology advice, and then I told someone else who knew how to make the computer programs work, make it pretty.
That's just lovely, Valerie, and I'm pleased that, well, I don't take any credit at all from some of this
You
work.
should.
But thank you. Which brings me to something else, because what you said about your with the graphic artist asking those questions that really helped you to think about how an ordinary person who's not a scientist may be asking questions about what they're trying to learn. So it brings me to the broader question of science communication to like the broader public, which is something that we're also trying to do, to be able to communicate that science is good, that science explains a lot of things, and that we should all attempt to understand the scientific point of view. What do you think about that? How can we be more, I guess, communicative and be more open and be more, make more impact in the way we communicate science and these what looks like idea or nerdy ideas and things that are inaccessible to the public? How can we make it a bit more broadly accepted by the public? Do you have views on that?
Oh, yes, I definitely have views on that. Thank you so much for asking. I think scientists have been their own worst enemy when it has come to communication. That too often scientists speak in overly complex, flowery language that individuals who are not well versed in the subject don't understand, and rightfully so, because it hasn't been made clear. Then the individuals who are trying to understand are left disgruntled and assume, well, I just can never get this. We as scientists, especially scientist educators, need to be able to educate everyone, not just the students in our classroom, but the common public. We need to be able to utilize terms that and analogies that are understandable to everyone, that that speak to individuals, that provide good pathways, that tell an entertaining story. God, scientists can be so boring sometimes. Like, come on, can't we tell a really cool story? One of the things I love about your animation and Claudia's clinical anatomy animations is that they're fun. They are fun and they tell a story, but yet all of the scientific material is accurate as well, too. That's what we need to do. And we need to inspire our students to be able to tell these same stories that we're telling to the individuals as well. So I would tell some of the scientists to get your head out of the clouds and interact. Work with a group of third graders and ask them, if you talk to third graders, primary school kids, they are excited, enthusiastic about the material. See how you're interacting with them and bring some of that enthusiasm to the high school students, to the college students, to the public community, so that they can see what we already know. That anatomy is really freaking cool and lots of fun.
It is. There's no question about it. And every time I speak about anatomy with undergraduate students, like with people outside of the ivory tower here, they are super interested. Everybody wants to know about the human body. It's so interesting. I think because we all have a human body, and then everybody's like, actually, yeah, how does that work? What does my heart actually look like? There's a lot of thirst for knowledge for that. So it's a real call to action again, to bring it out there. Yeah, get people involved in anatomy. When we think about anatomy, and since we all have this human body of ours, we think about different parts of our body and the bodies that we've looked at and dissected in our case. Valerie, what's your favorite body part?
That is, am I allowed to choose favorite three, or is that cheating? Okay,
Right,
so
all right. We'll
mine's
make an exception, but you have to
thank you.
maybe rank them a little bit.
Okay, so I will do it from third to first. Third, the pancreas. The pancreas is for those in the U.S. There is an old folks. I'm sorry, Haywood Banks. You're not old. You're seasoned. A seasoned folk singer who has a song about "Let us all sing a song to the pancreas." It has exocrine functions. It has endocrine functions. It is complex and cool, and it can also be really deadly if something goes wrong with it too. So, pancreas, number three. Number two, the ovary. The two ovaries, such small organs that, gosh, they affect every single body system in an individual with ovaries, with the production of estrogen and progesterone, and how the ovaries interact with the immune system. And if you look at how autoimmune disorders are more common in individuals, in XX individuals, um, and then once those ovaries stop working during menopause, let's look at all of the different changes that occur in the body. That is so flippin' cool. But then my top one, I started off looking at skulls as a biological anthropologist. I love the skulls, and I looked at dural venous sinus impressions in the skulls. So my top organ has got to be the brain. I mean, yeah, it's like the brain. It's so cool. There's so much that has yet to be understood about it. The things that we're starting to learn about it. How you can look at both the gross anatomy and then look at 21st century Neurone Connectome project. Beautiful images. That's where I stand for my 3 to 1.
Amazing. And I want to really point out how all three of yours are, of course, linked. So we know the hormonal influences on insulin function and the brain axis controlling our glucose metabolism and all of that. Those connections are the subject of intense research right now. And of course, the connections between our sex hormones and the brain and the changes that happen in the brain as our levels change. I mean, the dramatic rewiring of puberty and then the changes in menopause. I mean, of course, Valerie, you would choose three that are intimately interconnected.
Of course, yes.
Thank you for that. And what is your least favorite body part?
My least favorite body part. I don't think I have a least favorite body part to tell you the truth. I mean, like the rectum serves a purpose. So I don't want to. Perhaps the tongue, because sometimes when it goes on and on for too much, it gets people into trouble. How about that?
Okay, that works. It's so interesting because you are an anatomist and physiologist. So all of your choices had the functional aspect linked right to it. And the same with the tongue. It wasn't about, oh, when I have to dissect the tongue, it's weird. No, it's like people talk too much, linking structure and function. Very nice.
Your choices have been so much fun, Valerie, and yeah, I cannot dispute that. It's true that some people just go on and on and on, and you would like to tell them to shut up.
Yes.
So yeah, I can go with that. So thank you so much, Valerie. This has been such fun talking to you for this episode of the Body Banter, and I'm sure we'll have you again at some point. But thank you so much. We have learned a lot from you, lots of things to think about, some things to just take as things to just ponder as we go ahead in our journey learning about the human body. So from me, thank you, Valerie. Claudia?
Thank you.
Well, thanks, Valerie, for being here. It's always wonderful to have conversations with friends and with people who have already made such a huge impact in the field and have moved things forward and are continuing to inspire the next generation. And I hope this conversation will also get maybe that fourth-year undergrad student ready to consider grad school and become an anatomist as well. Thanks for being here with us. And thanks for a fabulous conversation.
Thank you all. I appreciate it.
Wonderful. So that wraps up another episode of Body Banter. We'll see you next time.
Thank you for listening to another episode of Body Banter.
We are Claudia
and Shegun,
and we look forward to having you join us for more conversations about the human body next time.